All right, so welcome everybody. Thank you for being here in one of the last talk. We made it through to this conference. I hope that you enjoyed it. And finally, I'm doing a real life talk with real people in front of me after a while. So I'm so happy about that. And yeah, so today I want to tell you how we managed to introduce Kotlin Multiplatform in an existing project. So I want to share the experience and all the struggles and the problems, but also the nice thing that we faced. So before starting, I quickly introduce myself. I'm Marco. I work at here, and these are my handles if you want to stalk me on the web. Yeah, so let's start. So Kotlin Multiplatform, pretty hype these days, but it's not a fake hype, it's a real hype, because I think that it's pretty cool. And the reason is that it's not like a classical cross-platform thing that shares everything, but it shares only some part of the code, and only the code that is not UI. So everything else, basically. And this is the core feature and the important thing that make the success of Kotlin Multiplatform, in my opinion, because sharing UI code is difficult. Every platform has their own thing, and finding something that connects and do common thing is really difficult. So if we focus to everything that is not difficult, then things are less painful. There are lots of architecture that we can target. We can target classic JVM things, so Android or desktop application or even backends. We can target JS, so the web, basically, and also native platform like Apple one and Linux and also Windows. But today we are in a mobile conference, so we are focusing on mostly the mobile layer, so Kotlin Multiplatform application for Android and iOS. But can be easily extended also to other platforms. So the topic of today is existing projects, but we need a common ground to start with also for new project to understand what it's necessary to do on existing one. So on new project, it's pretty simple to achieve. We can start building it directly from the Android Studio plugin for Kotlin Multiplatform, and you can install it. And in the wizard, we can choose KM application, and Android Studio basically builds everything for us. It builds a project with in a monorepo, of course, with 3 different folders: one for the Android project, one for the Xcode project for iOS, and the shared module for the Kotlin Multiplatform stuff. So on Android, it's simple, let's say, because all the stuff that we have is a Gradle project. So we can import that module easily on the existing application, and it's like, because it's Gradle, and Gradle can communicate with itself, and it's like having a classic module, like for example on your multi-module application. So pretty easy. All we have to do is basically nothing, because it's defined automatically, but if you have to do manually, you have to include the project in the settings.gradle file and then implement the dependencies. On iOS instead, it's difficult because there is Xcode that it doesn't talk to Gradle. And so what we need to do is create a binary and bundle all the stuff in a binary file. And in this case is the framework. And in order to do that, we can choose how to do it again in the Android Studio plugin. And the main two ways are two. The one is a direct connection with Gradle, so with the regular framework, and the other is using the CocoaPod dependency manager. So let's go and see more in detail. So the first one basically creates a framework whenever it's needed. And there is a task, a Gradle task, that is called by Xcode. And this task has a very long name. It's embed assign Apple framework for Xcode. And from Kotlin 1.5.20, it's embedded automatically in the Kotlin Multiplatform plugin, so you can't see it. But before this Kotlin version, there was the pack for Xcode task. That was a big chunk of code that was automatically put in the build.gradle file. So probably, if you have tried it, you have seen it. But now, basically, only the name has changed. And this Gradle task is called by Xcode when we hit the run button on Xcode. And when this task is run, Xcode and the task automatically understand which architecture we need. So if we are running the framework in the emulator, in the simulator, then we need the same architecture that we have on the machine. So x64 if we don't have an M1 machine, but this is another topic. And then if we are building for the device, we need an ARM64 architecture. And then also, if we are building for production or debugging, there are different type of framework. And everything is automatically understood and figured out by this task. The second way of providing a framework is the CocoaPod integration. And basically, the concept is the same, but the provider is different. So also in this situation, the framework is automatically created every time we want to run something on Xcode, of course, if there are changes. And but in this case, the framework is placed inside a CocoaPod repository that is a repository manager for iOS stuff. So, for example, like Maven for Android and the Java world. And then we can import the framework in the iOS project like for every other library. So in this case, it's more flexible if we are already using the CocoaPod dependency manager. And also, in this case, the architecture and the target are defined at runtime, and precisely in this long snippet of code that describe how to get it. So, as you may have think, on existing projects, we don't know if which architecture and which target we will need, because maybe we are not having the entire structure together. So, for example, in an existing project, maybe the this monorepo structure cannot be achieved because, well, could be a different reason. Maybe the repository are too big and too different, and it's difficult to put it together in the just for this thing, or maybe there are business constraints on it, many different reasons. So it's more unlikely to have the time to put it together. But fortunately, in software development, we can ship our code to another target, and this other target can use our code, and that's we call libraries. So in this case, we can choose a little piece of our existing code and decide to start using that for our Kotlin Multiplatform integration. So instead of starting from scratch. Okay, but this makes sense, but where to start? Well, as many things in software engineering, it depends. And but there could be different solutions. So, for example, it is possible to start from code that is boring to write multiple times, because if it's boring to write, then there will be an error for sure, because yeah, we get bored and we probably miss something. Or we can start, for example, from some feature or some part of the code that centralize the source of truth. Because, again, if we have one source of truth, we have only one point of failure. So, yeah, there is one place that we can mess up. And finally, all the things that summarize this kind of feature is the fact that we have to choose something that can be gradually extracted, because maybe we are not sure that Kotlin Multiplatform is the right solution for us. So we don't want to spend, for example, the entire time for migrating the entire network layer, because if you are going to spend too much time, and at the end, if at the end it doesn't work, then you have wasted basically your time. So, yeah, this is a very important part to start with, in my opinion. So, in reality, what are the places? Well, it depends, of course, but could be many. For example, one of the point to start could be DTOs. And for example, at my previous company, we started from this because we had some issue, let's say, with nullability on and on DTOs. And so, yeah, by having a backend in Kotlin and an application, and an Android application that uses Kotlin, made sense to have a single DTO defined with a single source of truth, and that actually worked. But there are many examples to start with, many others. So, for example, you can start from your common models that, yeah, are maybe the same. That is the same concept for DTOs. So you can have a single point with all your stuff of your business logic in it. Or then you can start from the beautiful utility methods that every project have. And again, if we define in one place an utility method, then maybe we're not gonna fail by writing in both sides. And another example could be analytics, because again, it's writing an analytics code is just boring. And yeah, many other places many other type of code that you can start with, and it depends, of course, on a specific project. To start a new project, to start integrating into an existing project, we have to create basically a library. Using the Android Studio plugin is not a good idea, because we don't want an Xcode project, an Android project, and stuff like that, but we want only our shared code. So to do that, I suggest you to use IntelliJ, that it has also a well-made wizard where you can choose a mobile library, for example. And with a mobile library, what is generated is basically similar for new project. For Android, we are going to generate, we are going to ship an Android library, so we are actually generate the binary, so and not a Gradle project. Instead, for iOS, we are still going to generate a framework because that's the only way to do it. But the way to ship those things are different. So in this case, you can have different choices, but for example, we shipped the Android library to a Maven repository, and instead the iOS framework with Cocoa Pod. And yeah, you can use maybe other iOS distribution framework, like for example Swift Package Manager, Cartage, or whatever else you want to use. We used Cocoa Pod because it was already there. And so yeah, after publishing this thing into the cloud, then the project will pull up the libraries and use it. So on overall, we don't have a monorepo structure, but rather 3 different repositories, one for the Android application, one for the iOS one, and one for the Kotlin Multiplatform library. All right, so let's dive into the actual, let's say, code, and let's try to understand how to publish the thing. So first, let's start with Android because it's simpler. But before starting, every snippet of code that I'm going to share in the slides are extracted from a sample that I wrote some time ago. And this sample is basically based on a true project, on a real project. So that's, yeah, you can have a look if you are interested. All right, coming back to Android, to publish our library, we can use the Maven Publish plugin. And in order to do that, we basically have to write just this line, and everything is work, and it's so beautiful that we need so few lines of code, and all we have to do is define the group and the version of the library, and then define, of course, where we want to publish it. And after this few lines of configuration, we can simply run a Gradle task, and our library will be published. If you don't want to publish online, let's say, you can also publish on your local machine, and yeah, this is pretty useful for debugging stuff and not wait for your library to reach the cloud. And after doing that, the library is published, and you can start using it in your Android code like it's a normal library that you use. So pretty simple. All right, now the trickiest part, that is iOS. And as I told before, we can't really use the solution for existing project because we need at the same time, or better, we don't know which architecture and which target the iOS developers are going to use. So we can't just decide for them, basically. So what we need to do is shipping everything, basically. And fortunately, there is something that we can use, and these are XC framework. And an XC framework is basically like a fat jar in the JVM world. And it's a framework that contains different architectures, so we can put together both ARM and x64 architectures, so for the simulator and the real device. And also we can ship together different targets. So both the bug release, of course, but also different platforms. So every platform that Apple has, basically. So iOS, macOS, tvOS, watchOS. This is pretty new because it has been introduced on during WWDC 2019. Yeah, if you're interested in the detail, you can give a look to this WWDC session. And before that, there was a FAT framework, and they work, but it was more difficult. In a FAT framework, you can't put different architectures, so you end up having a FAT framework for iOS and one for macOS. And yeah, it's painful if you want to target multiple things. Fortunately, the support for XC framework there is official support on Kotlin for XC framework, but it came a bit not a bit recently, so only from Kotlin 1.4.30. And before that, it was a bit painful because you had to manually build. You have to first build the framework, then build it together with the command line tool. But since I'm a lazy person, I made some Gradle script to make me build everything together with one task. But I'm not gonna go into the details because, yeah, it's out of context nowadays. But if you are interested and you are using an old Kotlin project, I wrote about that on my blog. So if you are interested, you can look to the code. So official support in order to build this framework, you have to first of all import it in the build.gradle file of your Kotlin Multiplatform library, and then in the Kotlin block you have to create the framework, and then for every target you have to add the target into the framework. So in this case, if you have, for example, a macOS block, you have to do this thing, and also for watchOS and every other platform. And after doing that, some Gradle task magically appears in your project, and there are three. The first one is we'll build both the bug and release version of the framework, and and the two others are gonna build the debug or the release. And this task will build and place the XC framework inside the build folder of your project. So after that, you have to retrieve it and ship it to the cloud, to whatever your iOS developer are gonna use. You can even put in a USB stick and ship to them, but yeah, it's not a good solution. What I did and what we did is, as I told before, using a CocoaPod repository. And so basically you can use a Git repository where the framework is stored. And in order to do that, you have, of course, to open a Git repository, and then you have to write a pod spec, a pod spec file that is a Ruby file with all the specification for your library. And this repository can be private. Yeah, of course, so the Git repository can be private, and yeah, if you are interested on doing that, I follow, and I suggest you to follow this tutorial on the CocoaPods website that is really well made, and I was able to to create it without any problem. So after, let's assume that we have this, we have built this repository, it's published. Now we have to import the library into our project. So to do that, I follow two main lines. I published the framework in two different branches. So for the bug versions, I publish it into the develop branch because, yeah, you probably gonna iterate faster, and so you don't want to waste tag for that. And then instead for the release version, I'm gonna use the master branch, the main branch, and then tag the release. So yeah, I'm sure what type of code I'm running. Yeah, to import the library, we have to write this thing into the pod file, where you probably have all the different other libraries that you're using in the iOS project. All right, so many things to do. We have to build the stuff, bring it, move it to another folder, publish it, tag it, commit, all these many things to do. I'm lazy, so I don't want to do it manually, so I've created a custom Gradle task that manages everything for me with just a command. So this task, basically, first of all, is going to switch branch based on the version that I want to build. So develop for the bug version. Then it's going to actually build the framework. Then it moves it from the build folder to the folder that I'm using for my CocoaPod repo, and then it's gonna update the version, the version number that is necessary for Xcode to understand which version is using. And then finally, I'm publishing everything to Git, so committing and publishing on the develop branch. So, yeah, everything that I need to do is write a command, and everything is performed automatically. For the release version, there is something that is basically the same, except for, of course, some little differences. So first of all, it check out on the main branch, and then it builds the release version, move the stuff again from the release folder, and then do the exact same thing, with the exception that in this case, I'm tagging a thing and pushing the tag. And yeah, that's it for what we have to do to publish publish our iOS library. Yeah, a bit painful, but yeah, with a bit of work, we managed to do. All right. Another thing that we have to have in mind when starting a new Kotlin Multiplatform thing is concurrency, because the memory model on Kotlin Multiplatform, or more specifically on Kotlin Native, is different from the JVM. In the JVM, we basically don't care so much about stuff, and we can do what we want. We can move stuff between threads and stuff like that. But on Kotlin Native, we have to take in mind that it's different, and so the rule of thumb is that if we have one thread, there is no problem. We can modify things, we can do whatever we want. But if there are more threads involved, then we can only deal with the immutable object. So we cannot modify something from a background thread that is, and then send it to the main thread and vice versa. So you're gonna probably be familiar with this exception because you are gonna see it quite sometimes because simply you forget that you're gonna forget, and I forget many times that it's a different memory model. And so to be able to deal with many threads, you have to remember to freeze the class and the object that you are using. And in order to do that, there is a freeze method that you can use. And yeah, it's different than having just the val and var of nullability. It's not enough to have variables with val, but we have also to freeze it. And yeah, it's a bit overwhelmed at the beginning, but if you start to plan things with the immutability in mind, that usually is not a bad way to architect stuff, then when you see the exception, the only thing that you have to do is just, oh, I have to freeze the object, go back, freeze it, and reiterate. A bit painful, but fortunately, things are changing. There is a new memory model that is currently in developer preview, so you can try it, but not in production for the moment. It's not suggested to do it. But at this week Kotlin event, we had the news that this memory model is going to be released with the beta version of Kotlin Multiplatform that is coming on spring 2022. So pretty close, and finally, yeah, we can deal with this thing more easily. All right, so we have seen a couple of things that we have to do, and let's try to wrap things up. So in order to start, when you start a new, to introduce Kotlin Multiplatform, you're gonna face, and we faced some difficult things. The first thing was how to properly organize the project without a monorepo structure, because every sample, every tutorial that I've seen online was with the monorepo structure, so it was a bit overwhelming at the beginning to understand how to properly set up stuff, but yeah, it was not so easy. And then another thing is how to build your DevOps and your architecture to actually provide easily the framework to the consumer, so to the Android, iOS, whatever other platform you are supporting. But for the experience, I have summarized a thing, and in my opinion, if you want to start with it, you have to start little, and then go bigger with things. And that's because at the beginning, you have to validate a bit the process, and you have to understand is the correct way to ship my framework, the library, is the entire pipeline okay for the team, and stuff like that. So you have to validate this thing before, and so you don't have, you can't start to migrate a lot of things. So for example, like I was saying before, you can't start and migrate the entire data layer because, yeah, you don't know if it's right for you, this entire thing. So after proving this, after proving everything, then you can move and start doing more and more things. Yeah, for example, we started with DTOs, like I said before, and we saw that this solution was okay for us. I mean, not okay, it was super cool for us to deal with. And so then we decided to also migrate and rewrite our persistence layer and have it on both Android and iOS by writing SQL once for all. So yeah, if you start with little things, then yeah, then you can go and share everything else. So these are some useful resources that I used for this talk. But yeah, next I'm gonna share the slide on. I'm gonna share the slide. So if you're interested to bump into it, you can have a look. And that's all for my side. Thank you very much for the attention. And if you have any kind of question, I'm here to answer.